Good evening to all. Am I audible? Good evening to all. Am I audible? Okay. So let us discuss a numerical problem on electrical analogous of mechanical translational system. So this is the given mechanical system. So in this numerical problem, they have asked us to write the differential equations. In this problem, they have asked us to write the differential equations governing the mechanical system as shown in this figure, and draw force voltage and force current electrical analogous circuits. So for this mechanical system, we have to draw force voltage and force current electrical analogous circuits and verify by writing mesh and node equations. Okay, so we have to write the mesh and node equations, and we have to draw the force voltage and force current electrical analogous circuit. Okay, so you just take a minute. You can note it down. I'll just give you a minute. You just note it down this, write down the question and note down this, draw the circuit. Okay, so let us proceed. So here if you observe, there are three masses. There are three masses M1, M2 and M3. So since there are three masses, what we have to do is we have to draw three free body diagrams. Okay, so I'll just copy it. So this is it. I have copied this circuit, actual given circuit, mechanical system, in the next slide so that I can compare and I can explain. So in order to draw the free body diagram for this mechanical translational system which has been given to us, see if you observe here, this is our M1. So draw a rectangular or square box and write M1 inside it. Now here if you observe, they didn't mention any displacement, okay, or velocity at M1 in the given diagram. So we ourselves, we will assume, since mass is M1, we will assume there is a displacement of x1 at this mass M1 and there is a velocity of v1. Okay, so if you observe, there are any applied forces at this mass M1, there are no applied forces, isn't there? Is no F. If you observe here, there is no F term mentioned here anywhere. So there are no applied forces. So opposing forces, okay, opposing force will be due to the mass itself, m1, fm1. So you can see I have written here, this is fm1. Other opposing force is due to this elastic element, that is k1. So fk1. So you can see here fk1. Other opposing force is due to this frictional element b1. So fb1. Another opposing force is fb1. And if you have see above this m1, there is b3 and b2. So one of the opposing forces due to the frictional element B2. So FB2 is another opposing force, and B3 is also there. So FB3 is another opposing force. So at mass M1, there is no applied force. All are opposing forces. Only opposing forces are existing here. So the opposing forces are FM1, FB1, FK1, FB2, and FB3. So to this square or rectangular box, you just put an arrow mark. It may be towards this box, or this arrow mark can be away from the box. Direction is not important. So simply put some arrow marks, maybe towards the box or away from, pointing away from the box. And write down FM1, FB1, FK1, FB2, and FB3. Okay, so this is the free body diagram of mass M1. So I will just remove this actual given circuit which has been given to us. So free body diagram of mass m1 is this. Okay, so here at mass m1 there are no applied forces, only opposing forces are there. So you just mention the opposing forces, you just draw it. I hope you have completed. Now we have the free body diagram. Now we can write on the opposing forces equation. So for Fm1 is equal to what? M1 into d square x1 by dt square. Fb1 is b1 into dx1 by dt. Fk1 is k1 into x1. Fb2 is b2 into d by dt of x1 minus x2. Why? Because b2 is between mass m1 and m2. So if you see here in this given circuit, b2 is between what? Between mass m2 and mass m1, whereas b3 is between mass m1 and m3. Therefore fb3 is equal to what? b3 into d by dt of x1 minus x3. So these are the opposing force equations. So for each opposing force, you can write down the equation separately. Okay, now by applying Newton's second law, so the sum of opposing forces should be equal to the sum of the applied forces. So here there is no applied force at mass m1. So applied force is 0. 0 is equal to what? Opposing force due to mass m1 due to friction b1, opposing force due to the elastic element k1, opposing force due to another friction b2, and opposing force due to one more friction b3. So the sum of opposing forces is equal to the sum of opposing forces is equal to the sum of the applied forces. So here there is no applied force, so applied force is 0. Opposing force, these are the opposing forces. Already we know the equations for each opposing force. Substitute these expressions in this equation and you will get this. You will get this equation 1. So instead of Fm1, write m1 d square by dt square x1 plus, instead of Fb1, write b1 into dx1 by dt. Instead of Fk1, write k1 x1 I will just erase all links. So instead of Fm1, you should write what? M1 d square by dt square x1. Instead of Fb1, you should write b1 dx1 by dt. Instead of k1, you must write k1 x1. Instead of fb2, you must write b2 d by dt of x1 minus x2. Instead of fb3, you must write b3 into d by dt of x1 minus x3. Okay. So consider it as equation 1. Now let us move further. Let us consider mass 2. So let us see how to write the free body diagram of mass 2. So once again, I'm going back to the question. I'm just going to copy this image. Now, how to draw the free body diagram of mass M2? Where is our M2? This is our M2. This is our M2. Okay. So if we observe at M2, is there any applied force? There is no applied force here. Okay. So, and they didn't even mention the displacement or velocity at mass M2. So we will assume displacement at M2 as x2 and velocity at mass M2 as v2. Okay. So applied force is not there. So what are the opposing forces? Opposing forces are force due to mass M2. Okay, force due to friction B2, force due to friction B23, and force due to the elastic element K23. So 1, 2, 3, and 4. Total 4 opposing forces are there at mass M2. So those forces, you can draw a square or rectangular box, write M2 inside that box, and put arrow marks maybe towards the mass or away from the mass. Direction is not important. And write down Fm2, Fb2, Fb23, Fk23. Okay. So Fm2, Fb2, Fb23, Fk23. These are the opposing forces at mass M2. Okay, so I just copied this image at this slide in order to show you how to write the free body diagram from the given circuit. I'm sorry, given mechanical system, not circuit. It is mechanical system, it's not electrical, so I should not say circuit. Okay. I'll just remove it. This is it. So this is our free body diagram of mass M2. So you can draw it in your notes. Whoever is copying it down, you can draw it, and yeah, you can write down the opposing forces Fm2, Fb2, Fk23, and Fb23. Okay, hope you have completed. So let us write down the force equation for each opposing force. So this is Fm2. Fm2 is what? M2 d square by dt square x2. Fb2 is b2 d by dt of x2 minus x1. Why? Because b2 is between mass M2 and M1. Fb23 is FB23 d by dt of x2 minus x3. Why? Because FB23 B23 is between mass 2 and mass 3. FK23 is K23 into x2 minus x3. Why x2 minus x3? Why? Because K23 is in between mass 2 and mass 3. Okay, so now apply Newton's second law at mass m2. If you apply Newton's second law, there are no applied forces. So applied force is 0. So 0 is equal to Fm2 plus Fb2 plus Fb23 plus Fk23. So what is Fm23? What is Fm23? Fm23 is m2 d square by dt square x2 plus Fb2 is what? B2 d by dt of x2 minus x1 plus Fb23 is B23 d by dt of x2 minus x3. Fk23 is K23 x2 minus x3 equal to 0. So this is our equation 2. So this is the force balance equation at mass m2. Okay, consider it as equation 2. Now let us draw the free body diagram of mass m3. For that I will end the screen. I hope you have written. Actually, you should not draw again and again the given mechanical system, but I have simply copied it in order to explain by showing this mass m, in order to show the free body diagram of mass m3. So if you see here, this is our mass m3. So at this mass m3, if you observe, there is no applied force here, isn't it? So even at mass m3, there is no applied force. So applied force is 0. And they didn't even mention any displacement at m3. So we will assume displacement of x3 at mass m3. And we will assume some velocity v3 at mass m3. So displacement at m3 is x3 and displacement at m3 is v3. Sorry, velocity at m3 is v3. Displacement is x3 and velocity is v3. These two terms we have assumed because it is not mentioned in here in the given mechanical system. They didn't mention that. So now there is no applied force. Okay, what is left over? Opposing forces. What are all the opposing forces at m3? If people can write down in chat box. We are. If you want, you can write down the opposing forces. So one opposing force is due to M3, Fm3. Another opposing force is due to what? V3. Another opposing force is due to K23. Another opposing force is due to B3. So what are all the opposing forces at M3? Fm3, Fb3, Fb23, K23, Fk23. So these are the opposing forces. So those forces that I have mentioned here in the free body diagram, you can see. I just draw a rectangular box or square box, write M3 inside it, and mention some arrow marks either pointing towards the box or pointing away from the box, and write down the opposing forces. There are no applied forces, so you write down the opposing forces: Fm3, Fb3, Fb23, Fk23. I'll remove this image so that I just copied it just to compare it with the, in order to draw the free body diagram, you have to draw it from the main mechanical system. Therefore, I just copied it. So there are four, yeah, someone have mentioned four. Yeah, there are four opposing forces. Now we have free body diagrams. We have drawn this free body diagram. For this free body diagram also, by applying Newton's second law, we have to write the force balance equations. So let us see the FM23, FM3, FB3, and FB23 and FK23 equations. So what are the equations? FM23 means M3 d square by dt square x3. FB3 is B3 d by dt of x3 minus x1. Why? Because B3 is between mass 3 and mass 1. Similarly, FB23 is B23 d by dt of x3 minus x2. And Fk23 is K23 kx3 minus x2. So by Newton's second law, applied forces must be equal to the opposing forces. Here applied force is 0. What are all the opposing forces? FM3, FB3, FB23 and FK23. They are the opposing forces. You just add all the opposing forces. Write down the respective equations. Instead of FM3, write M3 d square by dt square x3 plus, instead of B3, write B3 d by dt of x3 minus x1. Similarly, FB23, B23 d by dt of x3 minus x2 plus K23. K23 x3 minus x2 equal to 0. This is our equation 3. So we have got three force balance equations applying Newton's second law to each free body diagram. Now, actually, what do we want? We want the force voltage analogous circuit and force current analogous circuit. So these differential or force voltage, what are equations that we want? Okay, for the force voltage analogous circuit, what are equations that we want? The electrical equation should be similar to the mechanical translational system force balance equations. So we have three force balance equations. We have to write three electrical equations. Okay. So we have to write three electrical equations which should be similar to these three force balance equations. So now to get these similar equations, first of all, we already know that displacement and velocity relation. So dx by dt is equal to v. We already know that dx by dt is equal to v. So if dx by dt is equal to v, d square x by dt square will be dv by dt, and x will be equal to integral of v dt. So they consider these three conditions or substitute these three conditions in equation 1, 2 and 3. Consider these three conditions, that is d square x by dt square equal to dv by dt, dx by dt equal to v, and x is equal to integral of v dt, and just substitute these three conditions in your equation 1, 2 and 3. If you complete, just inform so that I can proceed. Okay, so you substitute those conditions in equation 1, 2 and 3. What do you get? m1 dv1 by dt plus b1 v1 plus k1 integral of v1 dt. So this fourth equation, number 4 is, we have got this equation from equation 1. I'll just copy the equation 1 and I will tell you what we have done. So I'll go back to equation 1. So this is our equation 1. So see, I have copied equation 1 from the previous slide. So here in equation 1, m1 is there. I have written m1 as it is. Okay. So d square x1 by dt square is what? dv1 by dt. So instead of d square x1 by dt square, dv1 by dt plus b1, I have written b1 here as it is. dx1 by dt means what? v1. Okay, plus k1 x1. Plus k1, what is x1? x1 is integral of v1 dt. Okay, I'll just expand the screen. Okay, so this is our equation 1. So we have modified equation 1 with, this is our equation 1. Equation 1 is modified to equation 4. So you just see m1, write m1 as it is, d square x1 by dt square is dv1 by dt. b1, write b1 as it is, dx1 by dt is v1 plus k1 x1. k1 into x1, instead of x1 we can write integral of v1 d1. Integral of v1 dt plus b2, write b2 as it is, d by dt of x1 minus x2 means d by dt of x1 minus d by dt of x2. So d by dt of x1 is v1 minus d by dt of x2 is v2. So v1 minus v2 plus b3, you just write it as it is, and instead of d by dt of x1 minus x3, right, what you can write? You can write v1 minus v3 equal to 0. So we have modified equation 1 to equation 4. Similarly, you take equation 2. So for equation 2 is modified as equation 5. So this equation 2 is modified as equation 5. So what is equation 2? m2 d square x2 by dt square. m2, instead of writing d square x2 by dt square, write dv2 by dt plus b2 d by dt of x2 minus x1, that can be written as b2 into v2 minus v1 plus b23 d by dt of x2 minus x3, it can be written as b23 v2 minus v3 plus k23 x2 minus x3, it can be written as k23, instead of x2 write integral of v2 dt, and instead of x3 write integral of v3 dt. We have taken integral common and we have written this equation 5. Okay. So this is it. Similarly, you can take equation 3 and you can replace x with v, and okay, you can replace, how to replace x with v we have already seen. So okay, so when you replace, you just substitute those three conditions, that is d square x by dt square is equal to dv by dt and dx by dt is equal to v, and x is equal to integral of v dt. You just substitute that, you will get equation 3 or equation 6 from equation 3. So m3 dv3 by dt plus b3 v3 minus v1 plus b23 into v3 minus v2 plus k23 integral of v3 minus v2 dt is equal to 0. So this is our equation 3. So equation 1 is replaced to, by replacing displacement. X is displacement, v is velocity. So by taking the relation between velocity and displacement, okay, so we can replace the displacement with velocity for each equation. So we have three free body diagrams. We have written 3 force balance equations. and you just remove the displacement with respect to velocity. So you will get from equation 1, you will get equation 4, from equation 2, you will get equation 5, and from equation 3, you will get equation 6. Okay, this is it for the given mechanical system. We have written these three force balance equations in terms of velocity. So actually, we usually write the force balance equations in terms of displacement. So whenever we want the force voltage analogous circuit or force current analogous circuits, we will convert the uh, free body diagram force balance equations, which are represented in terms of displacement, with the force balance equations which are represented in terms of velocity. So these are the force balance equations which are represented in terms of velocity. So equation 1, 2, 3 are represented in terms of displacement. Equation 4, 5, 6 are represented in terms of velocity. So I hope you have completed. Meanwhile, I was explaining, you might have written. Now write down force voltage analogous circuit. Okay. So force voltage analogous circuit. So what we have to do here is, you just what we have to do is we have to write down the electrical analogous elements first of all. Okay, for the given mechanical translational elements, you must write down the electrical analogous elements. So first of all, look at the given system, mechanical system, and see how many masses are there. Total 3 masses are there in the given mechanical system. Okay, therefore there will be 3 meshes in the LF, force voltage analogous circuit. In the force voltage analogous circuits, how many meshes will be there? There will be 3 meshes. Why? Because there were 3 masses, or we can even call them as 3 nodes or 3 masses in the given mechanical system. So there will be 3 meshes in the electrical system. Okay, force voltage analogous electrical circuit, there will be 3 meshes. Okay, that's it. Now what we have to do is, first of all, since we have to write the electrical analogous elements for the elements of the mechanical system, so first of all, just copy down all the elements of your mechanical system. What are all the elements in your mechanical system? Elements are M1. So write M1, put an arrow mark. Okay, just leave it. Next, M2, M3, write M2. Okay, put an arrow mark and leave it. Next, write M3. Sorry. Write M3. Put an arrow mark and leave it. What else is there here? V1 is there. So write V1. Put an arrow mark and leave it. Next, write B1. Okay, write B1. Put an arrow mark and leave it. Next, write K1. Okay, leave some space. Okay, write K1. Put an arrow mark and leave it. What else is there here? V1 we have written B2. So write B2. Put an arrow mark and leave it. Similarly, B3. Okay, you write B3. Put an arrow mark and leave it. Similarly, you write B2, B3, V1. V1 is over. We have written V1. You also write V2, put an arrow mark and leave it. Write B23, put an arrow mark and leave it. Write K23, put an arrow mark and leave it. That's it. I think I have covered all. I didn't write V3. Write V3, put an arrow mark and leave it. Okay. Now, after putting arrow mark and leaving it, now let us get back to M1. Okay. So what is the electrical analogous of M1? It is for you have already seen, you might be already knowing the force voltage analogous, force voltage analogy. Okay, analogous elements. Okay, so you must already know the force voltage analogous elements. So if you know the force voltage analogous elements, you can easily write it. So L is analogous to M1. So M1 L is analogous to M. So M1 you can replace M1 with L1. M2, instead of M2, what you should write? L2. Instead of M3, you must write L3. So what is V1? V1 is velocity. Okay, in mechanical system, V1 is velocity. So current is analogous to velocity. So instead of V1 can be replaced by I1. Similarly, V2 can be replaced by I2. V3 can be replaced by I3. So I have written only V1 here. So I have written only I1. So B1. Okay. So R is analogous to B. So B1 can be replaced in your electrical system with R1. B1 can be replaced by R1. Okay. B2 can be replaced by what? R2. B3 can be replaced by R3. Okay. And K1 is there. So analogous of K1 is 1 by C. Analogous of K is 1 by C. So instead of K1, you can write 1 by C1. And instead of K23, what you can write? 1 by C23. Okay. Is there anything else? K terms. Only these two terms are there. Okay. Instead of B23, what you will write? Instead of B23, you must write R23. Okay. So all these electrical analogous elements for the given mechanical system, I have written in the next slide. I have already written in the next slide. You can see it here. So this is it. Here sufficient space is not there. Okay. So there is no sufficient space here. I will put some space here. Wait. So these are the left side terms. Left side terms besides to the arrow mark. Left terms are the mechanical elements. Okay, right terms are the electrical elements. So these electrical elements are analogous to these mechanical elements. Okay, all these left side terms V1, V2, V3, M1, M2, M3, K1, K2, 3, B1, B2, B3, B2, 3. They are the mechanical elements which we have written from the equation 4, 5 and 6. Now in front of them they are analogous elements. So these analogous elements, we got it from the force voltage analogy. Okay, from the force voltage analogy, we got those terms. Okay, so just copy it down. Yeah, someone have written M1 L1, M2 L2, and M3 L3. Yeah, it is correct. So did you? If I hope you have completed. Now we can design the circuit, electrical circuit for the given mechanical system. So completed. Okay then. What I'm going to do is I'm going to take the mechanical system in order to explain how to draw the electrical circuit. So this is our mechanical system. So it's better if I take an empty blank page and I will just copy this mechanical system. So no need to draw this mechanical system again and again, but I am drawing it here. I'm just copying it here in order to explain. Okay, no need to draw again and again. So you just observe here. You just observe here how many masses are there. 3 masses are there. Okay, and you can see mass 2 and mass 3. They are interconnected. Mass 2 and mass 1, there is frictional element between mass 2 and mass 1. And there is frictional element between mass 3 and mass 1. And there are elements, frictional as well as elastic element between mass 2 and mass 3. Okay. So, all these 3 masses are having common elements, isn't it? All these 3 masses are having common elements. So, we can draw in either way. Okay, so if suppose this is our mass 2. Okay, since there are 3 masses, since this is force voltage analogous circuit, so there should be, since there are 3 masses, there should be 3 meshes, isn't it? 3 meshes, isn't it? There are 3 masses means there should be 3 meshes. So if you see here, mass 2 and mass 3 are having common elements. So I thought I will draw first of all mesh 2. Mass 2 means mesh 2. Okay, I am assuming mass 2 as mesh 2. Okay. With a pencil you must draw this first of all. Don't draw with pen if you are copying it down. You must draw with pencil. So mass 2 and mass 3 are having common elements. So what I am doing here, I have considered mesh 2 as mass 2. I have considered mesh 3. I am drawing here mesh 3. Okay, I am drawing here mesh 3 as mass 3. So my cursor is very sensitive cursor. It won't listen to me. So again and again it just, okay, mesh 3. Okay, so mass 2 and mass 3, they are having common elements. So I have considered a common link between mass 2 and mass 3. And mass 1 is having common element with respect to mass 2. Mass 1 is having common element with respect to mass 3 also. So that's why I am considering one more mesh. I am going to consider one more mesh which is common to both mass 2 and mass 3. So this is it. This is my mesh 1. Why I am mentioning it as mesh 1? Because it is my mass 1. Okay. So 3 masses, 3 meshes. Okay. Since there are 3 masses, there will be 3 meshes. So mesh, I am unable to write mesh here, but I will try my best. So here I have to write E, S, H and 1. At last I succeeded. Okay, so there are 3 masses, so 3 meshes, and there is common elements. There are common elements between mass 2 and mass 3. Therefore, we have put a common link or common branch between mesh 1 and mesh 2. And mass 1 is having common element between mass 2 and mass 3. Therefore, I have drawn mesh 1. Okay. So, mesh 1 and mesh 2, they have a common branch here. You can see mesh 1 and mesh 3 also have a common branch here. Okay. So, according to this mechanical system, this circuit is satisfactory. Okay. There should be common branch between M2 and M3. There should be common branch between M2 and M1. There should be common branch between M3 and M1. So I'm here M1 means, according to me, it is mesh. So there is a common branch between mesh 2 and mesh 3. There is common branch between mesh 1 and mesh 2. That is this. There is a common branch between, I will take a laser. There is common branch between mesh 2 and mesh 3. There is common branch between mesh 1 and mesh 2. This is my common branch. There is common branch between mesh 1 and mesh 3. That is, this is my common branch. Why? Because there is a common element between M2 and M1. There is common element between M2 and M3 and M1. There is common element between M2 and M3. Of course, there are more than one elements, but there is a common branch. Okay, that is it. 3 meshes. So this is how you must consider the meshes. So if there is no connection between any mesh, any two meshes, no need to connect that mesh with the other mesh. Means if there is no common element between any of the masses, okay, so if suppose m1 and m2 m3 don't have common element, then no need to connect m1, and there is no need to have a common branch between m1 and m3. Okay, so at present this is okay. Now I will take a pen. See, there is no applied force in any of these means there is no applied force at any mass that we have already seen. So forget about the source. We will not have any source here. So now mass m1. So what is m1? M1 means L1, which is purely okay. First of all, I will discuss the common elements between the meshes, that is masses. So there is a let us consider m2 and m3. I will take eraser and I will erase all this. I didn't take eraser, so I will just erase this. So in between M2 and M3. So in our electrical system, in between mesh 2 and mesh 3, you can say there are two elements. So what are those? K23. K23 means what? 1 by C23. B23. B23 means R23. So, okay. So in between, okay, in between mesh 2 and where is it? Yeah, this is my so in between mesh 2 and mesh 3, what is there? Common elements are K23 and B23. K23 means 1 by C23 and B23 means R23. So 1 by C23 means capacitor should be connected in series to which element? To the resistor R23. So you can draw a capacitor. You can draw a capacitor here and you can draw a resistor here. So what I will do is I will just erase the middle branch. I'll just erase it. Okay, I will redraw this. Okay, so in the middle, common between mass 2 and mass 3, what is there? There is a capacitor 1 by C23. So since it is mentioned 1 by C23, capacitor will be in series with the another element. What is the another element here? Two elements are there, resistor and capacitor. What is this? C23. And this is resistance is R23. R23. I hope you have understood. Okay, now we have drawn the common element between mesh 2 and mesh 3, that is M2 and M3. Now, what is the common element between M2 and M1? That is B2. B2 is the common element between M1 and M2. So, mesh 1 and mesh 2. What is common element? B2. B2 means what? R2, resistor. So, you can erase this line and you can draw a resistor. I am not erasing here. And you may just write R2. This is R2. Okay. Similarly, what is common element between mesh 1 and mesh 3? What is common element? Mesh 1 and mesh 3. It is B3. Oh, B3 means R3. So you can draw a resistor here. You can erase this line. You can, if you want, you can erase it. Okay, I have erased it. And I can draw a resistor now. That is R3. Okay. So something I am drawing it. I'll once again draw it. I couldn't draw it properly. So, oh, this cursor is not listening to me. It's okay. I'll try one more time. Where is my cursor? I'm unable to see it. This is it. Okay, so this is my R3. Okay, this is R3. Now, common elements are over. Let us consider mesh 1. What is purely connected to mesh 1? M1 is there, B1 and K1. These three are purely connected to M1. So that is in mass 1, how many elements will be there? One is analogous of M1, another is analogous of B1, another is analogous of K1. Total 3 elements will be there purely in mesh 1. Okay, purely in mesh 1, there will be total 3 elements. Okay, which are not interlinked to any other mesh. There will be total 3 elements. So I will just erase here. I will draw that. I'm erasing this mesh 1 here. So this is our mesh 1. So how many elements will be there? Total 3 elements. What are those 3 elements? One is the M1. M1 means L1. So you can take a pen and you can draw an inductor here. You can erase that line. You have to erase actually. I'm not erasing it. This is L1. After L1, what is K1? 1 by C1. 1 by C1 means capacitor should be in series to the other elements. So C1. Oh. Okay, I'll just connect these elements. Okay, my cursor not at all listening to me. Next one is B1. B1 means what? R1. So draw a resistor here. So here I have written C1. C, what is it? C1. This is C1. This is R1. Okay, so these are the elements in mesh 1, purely connected to mesh 1. So what are the elements that are purely connected to mesh 2? Let us see. Purely connected to mesh 2. Is there any element? Only mass M2 is there, nothing else that is purely connected to M2. So only mass M2. M2 means what? M2 means L2. Okay. So you just connect, I will just erase this line. Okay. You draw an inductor here. I will draw an inductor. I'll draw an inductor. Only one element, that's it. This cursor is very sensitive. So, see, I have holded it very lightly. This is inductor L2. So, what is connected purely to mesh 3? So, what is connected purely to mesh? No other element except M3. M3 means again inductor, isn't it? Again inductor. So, what you have to do is you have to draw an inductor here and write L3. I'll just erase it, erase the line. Okay, I have already drawn the inductor. I will just join it. So this is my L, mesh 3, L3. This is R3. Okay. So this is our circuit. This is mesh 1. I can't write. Okay. So this is our circuit. I hope you have understood. Okay. M2 means only M2. Yeah, it's M2. So I hope you have understood. This is our circuit. You just copy it down. So since this is KVL, okay, since this is KVL, so we have to consider what? We have to consider the loop equations, isn't it? We have to write the loop equations now. So you have to consider the loop equations. Okay. So here velocity, okay, velocity, instead of velocity, what you should write? You should write current. So you just draw loop equations. Your wish, you can assume any direction. You can assume loop current. I'm sorry. You just mention some arrow mark and write down in mesh 2, write down small I2 or capital I2, your wish. Okay, I2, loop current I2. So what I will do, I just erase this meshes, mesh 1, mesh 2, mesh 3, whatever I have written, and I will write loop currents. Mesh 3 I have written here, I will just erase it. So mesh 1 I have written, I will erase it, and I will mention loop currents. So this is I1. You can assume any current direction, either clockwise or anti-clockwise. This is I3. Sorry, this is not I1. This was mesh 2. Mesh 2 means I2 current. And this was our mesh 1. So usually we consider the left side loop usually as mesh 1. That's why by mistake I wrote here I1. This is not I1. This is I2. I will write I2 properly. This is I2, this is I3, this is I1. I have assumed all currents in clockwise. Your wish, if you don't want, no need to consider currents in clockwise. Okay, so if you want, you can consider currents in anti-clockwise. So if you have completed, I will just move forward. So to be frank, whatever circuit that I have designed here, earlier I didn't design in the same pattern. So if I show you that circuit, you may get confused, maybe. You may get confused, maybe, or you may not get confused. If you have the clarity of the concept, you will not get confused. So I hope you have written. Did you complete? I will just save it. So this is the circuit that I have earlier designed. I wrote here mesh 1, mesh 1, mesh 2 and mesh 3. This is how I wrote. So same circuit actually, but while explaining to you, I have drawn mesh 1 up, and mesh 2 on the left side and mesh 3 on the right side, but I didn't do earlier in that way, that pattern, but both are correct. Okay, both are correct. You can write the KVL equations on your own. You will get the equations will not change. You just observe here. I3 is there, L3, C23, R23, R3 is there. So go to I3. Where is I3? This is I3. So just see L3, R3, C23, R23. Same terms are there within this loop. I2, what is around I2? What all the elements are there around I2? L2, R2, C23, R23. Where is I2 here? This is I2. L2, R2, C23, R23. Same elements will be there. Only the thing that I have considered is assume the loops somewhere else. Okay, I didn't follow this what already is there in this PPT. So I didn't follow this. But you need not worry. If you have the clarity of the concept, you can play with this. Okay, you can write the equations on your own. You can draw the circuit on your own. So if you want, you can even copy this and you can compare both the circuits. You people better, whoever is writing it down, you just copy this also. So earlier one, it is there. I'll just end the show. I'll write keep and I'll just save it. Okay. So you just draw this circuit also and you can compare both the circuits. I will try to conclude within 10 minutes. 10 to 15 minutes, I'll conclude this topic. Okay, this is it. I hope you have completed. So write down the KVL equations for each mesh. If you write the KVL equations, you will get these equations. You just write it down on your own and verify what I'm showing on the screen. If you complete in form, just write down these KVL equations as quickly as possible. Okay then. Let us go to force current analogous circuit. Okay, so we already know the mechanical system elements. Okay, from the equation 4, 5 and 6, write down V1, V2, V3, M1, M2, M3, K1, K2, 3, B1, B2, B3, B2, 3 again. And from the force current analogy, write down their corresponding analogous elements. So V1 is velocity. So voltage V1 is analogous to V1, velocity. Voltage V2 is analogous to velocity V2. And voltage V3 is analogous to velocity V3. So for angular velocity, instead of writing V1, V2, V3, you can write velocity as, you can replace V with omega. So C1 is analogous to M1, C2 is analogous to M2, C3 is analogous to M3. 1 by L1 is analogous to K1, 1 by L23 is analogous to K23, 1 by R1 is analogous to B1. 1 by R2 is analogous to B2, 1 by R3 is analogous to B3, 1 by R23 is analogous to B23. So just write it down. Write down all the analogous elements. Okay, so now let us design the circuit. Let us consider the mechanical system. No need to draw the mechanical system. I have copied the mechanical system in order to explain you how to draw the electrical system. So, how many masses are there in the mechanical system? M1, M2, M3. So, I have considered three masses means three nodes will be there. Node 1, node 2, node 3. Okay. Node 1, node 2, node 3. Three nodes will be there. So, instead of showing you if I can draw it, so let me see. I will take a blank page. This is our mechanical system. So we have to design the force current analogous circuit for this system. Okay, so there are three masses. So you can consider the nodes according to three masses means three nodes will be there. So you can consider the nodes according to your diagram. You can consider like this. You can consider like this according to your diagram. Okay, no need to follow me, but you can do this also. So this is it. So this is node 1. I'm sorry, this is node 2 according to, I am drawing according to this mechanical system. This is node 2. This is node 3. This is node 1. Sorry. Okay, this is node 1. Now so assume node voltages. So my cursor won't listen to me. That's one of the drawback. So it won't listen. It's very sensitive. That's the reason. So node voltage V2. I can't write. Node voltage V2. Node voltage at node 1, node voltage V1. At node 3, node voltage V3. Okay, now in between V1 and V2, what is there? In between M1 and M2, what is there? B2 is there. In between M1 and M2, B2 is there. What is B2? B2 is 1 by R2. B2 is 1 by R2. So only one element is there, even if it is whether it is R2 or 1 by R2, it doesn't matter. So connect a resistor in between node 2 and node 1. What is the resistance value? It is R2. Resistance is R2. Write R2 here. Okay, now in between node 2 and node 3, there are two elements, isn't it? K23 and in between M2 and M3, K23 and B23 are there. So in between node 2 and node 3, there will be two elements. What is K23? K23 is 1 by L23 and one more element is B23. What is B23? 1 by R23. So K23 is 1 by L23 and B23 is 1 by R23. Since the inductance and resistor both are represented in terms of 1 by L and 1 by R, therefore they should be connected in parallel to each other. Okay, in between these two. So what we have to do is you just draw like this. Draw an inductor. Draw a resistor. The inductor and resistor both should be parallel to each other. Connected between these two nodes. No, between which nodes? Node 2 and node 3. Okay. So what is this? L K23 means L23. So L23. B23 means R23. R23. Okay. This is it. Common elements in between mass 1 and mass 3. What is common? Where is my cursor? Yeah. In between mass 1 and mass 3. What is common? B3. What is B3? B3 is 1 by R3. Only one element is there. Just draw here a resistor and write R3. Okay. So I didn't draw the same circuit in my PPT. I didn't give the same circuit, but I am drawing it according to this circuit. So maybe you will also think in the same way that I am thinking. Okay, now what are all the elements restricted to each node? Okay, at each node. At M2, at node M2, what is there? Only M2 is there. Okay, opposing force due to M2 is there. What is M2? M2 means capacitor. So M2 means capacitor. So draw a capacitor. Okay, draw a capacitor at node M2. What is M2? So C2. What is it? Sorry. It is C2. Okay, this is C2. Next, at node M3. What is there at node M3? There is no other element. M3 means what? C3. So draw a capacitor at node 3. C3. So what is purely connected to M1? There are three elements. M1, K1 and B1. So capacitor is C3. So capacitor, it is, at M1, capacitor C1. So at M1, capacitor C1 and K1 means 1 by L1, B1 means 1 by R1. So these three elements must be connected. How these three elements must be connected? Okay, at M1. This is node 1, isn't it? At node 1, how the capacitor C1, how and 1 by R1 resistor and 1 by L1 inductor, how they should be connected? They must be connected in parallel to each other, isn't it? They must be connected in parallel to each other. So what I'm going to do is, I'm going to consider three lines here. One is capacitor, one is capacitor, another one is resistor or inductor, whatever. Resistor, another one is inductor. So inductor. Okay, these three elements. So all these elements, this C2, okay, and this C3, and what is this? C1, R1, and L1. All these three are connected in parallel to each other. So they will have a common reference point. Or they will be connected to the reference node, I can say. Okay. Okay, so this is my circuit, electrical circuit. I will just save it. I will just save it. So you can copy it down. You can copy it down. If you have doubts, you can mention in the chat box. I'm about to complete. We will write the force current equations and we can conclude. If you have completed writing the circuit, if you have completed drawing this circuit, you can write the force current equations, nodal equations at each node, node 1, node 2, node 3. So as I have already shown you, the circuit that I have designed, that is somewhat a bit, it looks different, but it is same. Okay, it may look different, but it is same. So if you complete, just mention completed, so that I hope I am not confusing you. It's very simple. Only the thing is, you have to analyze the circuit. You must know the common elements between the masses. You must know the elements which are connected only to each mass. Okay. You must know the elements which are connected only connected with respect to each mass. So if you are able to identify that, you can easily draw it. You can easily draw it. Okay, I will just go to the next slide. This is it. This is what actually I have drawn. If you want, you can copy this also quickly. You can copy and you can write down the equations. I am about to conclude. Were you able to understand, or is it difficult to understand? If you want me to repeat, anyone, if you want me to repeat, you can mention. I will repeat it. Anyone can mention well if you want me to repeat. Because it's already late and you might be hungry, some of you. So if anyone wants me to repeat any part of this lecture, you can mention in the chat box. I will repeat for that particular person. So you can see here at node 1. Okay, node 1. What is at node 1? Only elements connected to node 1 are what? C1, L1 and R1. So of course in the previous diagram, this diagram, C1, R1, L1, I have written node 1 at the middle. Because according to this diagram, I thought M1 is in. It's okay. It's obvious. This is right. What I have drawn with my free hand is correct. See, to node 1, C1, R1, L1 are connected. Okay, in this diagram also C1, L1, R1 are connected to node 1. In between node 1 and node 2, R2 is connected. In between node 2 and node 3, L2, 3, R2, 3 are connected in parallel. Only to node 2, C2 is connected. Only to node 3, C3 is connected. In between node 1 and node 3. Did I connect in between node 1 and node 3? Yeah, I have connected R3. Yeah, I have already connected R3. This is it. So this may look different, but both are same. Both the circuits, both the electrical circuits are same. Force current analogous circuits are same. Okay. So write down the Kirchhoff's current law equation at node 1. What is it? C1 is there. So C1 dV1 by dt plus 1 by R1 V1 plus 1 by L1 integral of V1 dt plus 1 by R2 V1 minus V2 plus 1 by R3 V1 minus V3 is equal to 0. That is one equation at node 1. 3 nodes are there, 3 nodal equations you will get. Of course, at reference node, we will never write the nodal equation. At reference node, voltage is 0. Okay, at reference node, voltage is 0. I hope you have completed. At node 2, equation is what? C2 dV2 by dt plus 1 by R2 V2 minus V1 plus 1 by L23 integral of V23 minus V2 minus V3 dt plus 1 by R23 of V2 minus V3 equal to 0. And one more equation at node 3 is KCL equation at node 3 is C3 dV3 by dt. I'll take the laser. C3 dV3 by dt plus 1 by R3 V3 minus V1 plus 1 by L23 integral of V3 minus V2 dt plus 1 by R23 V3 minus V2 equal to 0. Now you can compare equation 10, 11, 12 with your equation 4, 5, 6. Both will be similar to each other. Okay, both the equations will be similar to each other if you compare these three equations with the equation 4, 5, 6. So you just mention whether you have understood or not. Anyone can mention if this numerical problem is over. So if anyone wants me to repeat, they can mention in the chat box. Any part that you want me to repeat, I will repeat it. Otherwise, I will conclude this. Did you understand? If I understood, okay. So you just mention understood, that so that I will come to know that you have understood, and I have almost I have completed. It's over. Okay, the numerical problem is over. At last, we must write that both the nodal base equations and the mechanical system equations are similar to each other. That statement we have to write. Okay, then. Thank you for attending this class.